The final challenge in the web category is sanitizer. This only had one solved by Strelick. It says, what does it truly mean to sanitize something? What is sanitize? Is this challenge solvable? Admin bot code is provided running Chromium, at least 109. So again, I didn't solve this challenge. I referred to the write-ups from the challenge author to help solve this. You can find it at this URL. So the challenge author had a intended solution, and the one person that solved it used something else. And we're going to be talking about the non-intended solution. I played with the intended solution for a while, and I think it is very cool. And if you haven't seen the CSS container queries, I recommend checking them out. But we're going to be, in the intended solution, they use these container queries to kind of pinch a nearby element and determine its width. In the unintended solution, we're going to move a image off screen and use lazy loading, and depending on the width of the font, we'll know if the image is on screen or off screen because we'll get that network request. Anyways, like I said, I'd recommend checking this out. I did not solve it during the CTF. I'm just going through and solving all of them afterwards just to make sure I really understand everything. And with that, let's get started. So we're given three different things. We're giving sanitizer.zip, we're given a netcat port, and we're given the website. Let's take a look at the website. It's a very simple website. It just says irisCTF, redacted, 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 and the page source is actually given to us. So we'll take a look at that. So I think index backup. So this is the page source, nice and simple. It's going to read flag from local storage. And if it doesn't exist, it's going to use this placeholder flag. The flag is 35 characters long. It's going to set the flag in here. So this will be, irisCTF redacted. Then it's going to read. So we have an injection. It's going to read location.search. As a reminder, location.search would be a.com, blah, and then location.search would be AOFUH, blah, 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 blah. So that's search. And it's going to use the new setHTML call, which uses the sanitizer. So this is what the challenge is called, sanitize, and this is what it's referring to. So this is like a brand new kind of like, I guess, a replacement for DOM Purify, if I understand correctly. But it's built into the browser, it's experimental, and it's supposed to completely like sanitize any given HTML. So instead of using inner HTML for untrusted input, you can now use the sanitizer API. You can see there's like a very silly XSS here where there's a script, and you can see it's able to sanitize the script tag. So again, at first sight, this seems absolutely impossible. Like, we're supposed to bypass Chrome's sanitizer and leak a token on the page, which is pretty insane for a CTF. Like, if we actually had a real bypass, that'd be some serious bug bounty money. But thankfully there is a bug. The challenge author mentioned that if you're familiar with DOM Purify, there was a CSS bypass related to that, and so we're going to be exploiting that. And so the idea is we're going to be using some CSS injections, because CSS is allowed by the setHTML to read things off of the page. Cool. So the challenge author has a link to a page. So this attack is not new, but it says the standard technique for doing this is due to Michael Benkowski. And so this is the URL. He has a very great article called Stealing Data in Great Style. And there's a bunch of different exploits in here. We did a CSS injection in the previous challenge. If you haven't seen that one, it's mock review. So we're kind of doing an extension of that. But the difference is, in this one, we're going to be using fonts, and specifically a thing called ligatures, I think, ligatures. And so a ligature is the combination of two characters. So the exploit we're going to be doing is, let me go back. We're allowed to inject content here, but it has to be sanitized content. The sanitized content is allowed to include styles. So we're going to embed some styles, and we're going to specifically embed some fonts in those styles. And we're going to do a really neat cross-site leak such that we're able to read this character by character depending on the font. Just to actually take another step back, if we remember top level view, we get this netcat port, the bot is going to go to this netcat port. It's going to, we're going to send a URL to this netcat port. The bot's going to go to the URL that we provide it. And so that URL provide is going to be some website we control, probably an ngrok. And then from there, we're going to, do a bunch of cserfs, iframes, cross-site leaking to steal that token. And we should probably look at the bot code. I'm kind of jumping all over the place, but we were given two files, the index.html and the bot code. The bot code is pretty standard. There's one non-standard thing, and that's hide scroll bars. So typically for these font attacks, they abuse a scroll bars thing, which I'll talk about in a second. But otherwise, it's pretty standard as far as I know. It's going to hide scroll bars. Otherwise, it's just Puppeteer going and viewing a page. When it does it, first it's going to go to sanitizer web chow, this domain, and it's going to store the flag in local storage.flag, and then it'll go to your website. We already kind of knew that because it was going to read window.localstorage.flag. So again, the challenge is very obvious, just hard to actually exploit. Like there's no guessing. The flag is right here. Anyways, so going back to this article. So we're going to be abusing these. And so, like I said, on this web page, we're going to be embedding fonts. And the attack is you can match these ligatures and set custom widths on these ligatures. So we're going to be creating new fonts. And these fonts, we're going to define a ligature such as irisCTF. We're going to say that's one word or one ligature. And we're going to give it a width of a huge amount so that it goes off the page. And then we're going to assign the width of everything else to be 0. And using this trick, we can brute force character by character. So there's two techniques. Like I said, there's the unintended way and the intended way for actually getting that leak called back to your server. The challenge author used the new CSS size selectors. So you can define this thing, a new thing in CSS called a container, and then you can query its size. And so they did this, and there's a little bit of a trickery because you're not allowed to specifically query a container size directly. You have to do it with a child. And so they do this kind of clever thing where they define, there's this div here, and they define another element over here, and they define the overall width to be like 500. And then depending on the font, they can see what the width of this, and if it's being pinched or not. And if the width is less than a certain amount, they know that this must be large. And because of that, then they load a image in the background. It's pretty cool. I played with the queries for a while, or the containers for a while. They're cool, but I think the loading the images off the screen just seemed a little bit more reliable if I was to do it in the future in the CTF. And I like to save all my scripts in case I get a similar challenge. So I ended up fully exploiting that one. So like I said, the other exploit technique is this images. So what instead we're going to do is we're going to, again, generate these fonts and go character by character. And so let's say we generate a font that has a ligature of this, irisCTF open bracket R. If it matches this, this is going to be huge. At the very end, we're going to inject an image, and we're going to put loading equals lazy on that image. And so what Chrome will do is it won't actually load that image unless it's within some distance of the viewport. And so since it's so far off screen, Chrome won't load it. But if we make a mistake, not a mistake, but if we're brute forcing, let's say we're doing irisCTF open and A, that doesn't match anything. And so this is going to be really small, and the image will be on the screen. So we'll know that that was not part of the flag. I have a playground to play with this. Let's actually So here's a little test demo before we go into the real solution. So I modified the index.html to kind of explain how this attack is going to look. So this is the same. It's going to load the flag from local storage. This is the same. It's doing an assert. This is the same. It's setting the flag inside. And this is where the new stuff is. Eventually, we're going to load this. So like in the real script, we take it from the search bar and we do the set HTML. We're just manually injecting it so we can play a little bit faster and we don't have to mess with the URLs. Cool. This parameter, there's two parameters that kind of go into the script. Actually, I'll start with this. There's a style and an image. We're loading those and we're injecting them into the HTML. We're defining two variables. One is known, so this is the known portion of the flag. We know that the test flag is redacted. So we're just starting with an R, and we're going to guess that the next character is an E. So this is the correct character. Actually, let's do the wrong character first. So let's say our guess is A. Like I said, we're going to request a font. So on this port, I have a Flash server, and the Flash server will generate fonts with this ligature here that is very large. And I'll talk about how that happens in a second. And we give this a font family name. Then we have a flag. We make the font size really big. It just makes the exploit a little bit easier. We do body display flex, so that puts everything into a single row. Otherwise, the image would be below everything. But if you do display flex, you actually don't need flex direction. It's just a nice reminder. It means all contents are in a row. Then we have our flag. So we're going to say that this has a specific font, and we're going to give it a background color of red. That's just because in our new font, everything is actually blank. It only has a width, so it's hard to know if your exploit's actually working. So you just make it red. And then the very final thing is that image. Like I said, it's loading lazy. So it'll only actually load from this URL if it's on the screen. And so if it's a bad guess, the image will load. And if it's a good guess, the image won't load. And we can see where this is our leak parameters, our known, our guess. And I set some other stuff just to make it easy. I guess I don't actually need this anymore. Cool. And so this is, if I refresh, this is what a bad guess looks like. So we are requesting a font of RA. So this is our known key and this is our guess key. It should be redacted capital R, capital E. Because of this font, it's just not going to match. But if we do a ligature of R, capital E, which does match, so it's matching all of this, we should get a giant box. This is a huge box. And if we refresh, for some reason it's, maybe I have to do a smaller screen size. There we go. Like I think Chrome's how they detect if it's on the lazy loading. Oh, sorry. Let me go back and explain. I'm looking at this network request down here, and I see that there was a leak, meaning that it tried to load the image. And so the image is right here. I just scroll to the right. It's pretty close to the viewport, so Chrome has decided to render it. But if I move this all the way over here and make it very small, now when I refresh the page, there is no load, and so it's very far off of viewport. And so and you see if I make it small, the image is not loading. But as I grow the window just a little bit, eventually Chrome decided it's time to lazy load this image, and we get the leak. So anyways, that's like the top level highlight or overview of the actual exploit. And so now I'm going to dig into the exploit script. But it's pretty cool. Like, to summarize, we're starting with this text is on the page, the flag is on the page. We're going to inject a custom font. The font is going to match subsections. The font is going to set every character to 0, except for the subsections, the ligatures. And if the ligatures are going to have a huge width. And so as long as we guess the correct subword, this whole line is going to be huge. And we're going to put an image at the very end of the image. And if we guess the correct image, the image will be, guess the correct substring, the image will be off the page, and so we won't get a hit. But if we guess the incorrect flag, the image will be on the page and we will get a hit. Like I said, normally, the reason we're doing this image off the screen is because of hide scroll bars. The default way to do this, that's outlined in this article, is to actually load. You can load images on scroll bars, and so you would just see if your content goes off the page, a scroll bar will be loaded, and this URL will be loaded. So doing an image off the screen isn't that much harder. There is one trickery. I'll talk about this later, but dealing with caching. Cool. Yeah, so that's everything. So let's start talking about the real solve. So this is the exploit script. And so this is the page that the bot is going to view. So we have a base URL, which is that sanitizer web page. And so this is where the flag is. We have our ngrok, which is just our server. We have a Python script, a Flash server running in the background. And I'm going to iterate between these two. So this is the exploit.html and then our Flash server. The first thing we're going to do is we're going to ask for the current flag. It's going to do a character by character brute force. It's very slow. And so if you get to a known flag point and there's a timeout or something, you just start at that known brute force. Anyways, so while the known flag, the last character is in a closing bracket, we're going to iterate through all of these possible characters. For all these characters, I fetch flag again because it's possible that if on the server end, what it's going to do is I'm going to get a hit for all of these because these are all the incorrect next character. Eventually there's going to be a skip. And so if there's a skip, like it goes from R to T, of the image pingbacks I get, I know that S wasn't loaded, and so therefore S is the next part of the flag. And so right here, the server tells us we already have the next part of the flag, so we need to restart. So that's what that break is for. Anyways, we're going to go character by character, and we're going to update the URL of the iframe on this page. And remember, it's the bot that's viewing these. And the URL we're going to update is we're going to send the URL to link, rel, style sheet, our ngrok, our known flag, and our guess. We're actually going to update the iframe twice, and that's because we need it to cache this CSS. So this is one of the trickeries, unfortunately, or I mean, I guess fortunately. So when it actually embeds, actually let's go back to this playground. So I'm embedding this, so I'm actually doing this link rel style sheet thing. And so on this playground, it's, it's actually link rel style sheet. Is it source? No, it's href. Href is equal to blah. And then underneath the image is defined. It takes a second for the style sheet to be loaded to make the flag very big. And because of that, this image will be on screen for a second. We don't want that because we want lazy loading off. So first thing we do is we cache the CSS so that the browser loads it instantly and the image can be properly moved off screen. So this is just to make sure there's caching, basically. And then after we've cached the new style sheet, we'll do the exploit with the style sheet and the image. And this also caches the font. So we have to cache both the style sheet and the font. Cool. And then, like I said, we're going to go character by character, and the callback goes to the server. So this is our server. When we do the actual POC, we're just going to do the last two characters because it's super, super slow. Because we have to go character by character, and we're doing like delays of a second in between each because we have to wait to see if we get a ping back or not. So a couple different things. This is the flag route. So this is how the script checks what the current flag is. There's a global variable here. And it just checks every time I ask for the flag. Actually, I'm gonna skip this for a second. First, I'm gonna talk about leak, and then I'm gonna go back to that function. So leak is the image that is called that's either on the page or off the page, and I get a known and I guess, and I get the known flag, which should just match flag. I guess I don't really need this, and also guess. And so I have this thing called a ping map, and so the ping map looks something like this. So I have it on the top. So the current flag is this. So in the ping map, there'll be something like this, and then an array, and it's going to go A, B, C, D, and let's say F. And so with each image hit, I'm going to save the next character onto the array, and so then I know it's not that, C, D, E. And then when I ask for what the current flag is, it's going to go through that array, and we see that there's the E is missing, and because the E is missing, we know that that ping didn't happen with the E, and so the next character of the flag is E. It's also possible there's like a network delay or something, or could be a bunch of stuff. It's not the most reliable script, but so far it's been pretty reliable. So since E is missing, we know the next character is E, and we can update everything and start brute forcing from E. I think the next character is an A here, so it'd be missing the first one. But yeah. So we have that ping map. Cool. Like I said, we're going to be loading custom CSS every time. And so we have this is our route for generating the CSS. This is imported. No, we're doing the link style rel, a link rel style sheet href tag. And so this is where we load it from. It's just going to generate some CSS. So we have our font family. It's saying where to load the font from, font family stuff. Yeah, it just builds it. Cool. This is the header to generate the font. So we have to generate the fonts every time. To do that, there's a tool called FontForge. This is referenced both by the challenge author and by this script, or this page here. I think it's a well-known tool. And so what FontForge does is allows us to generate fonts from SVG files. So here I'm going to generate an SVG file, the contents of one. It looks like this. So this is our font SVG file. We're going to define a font that's called hack. And so this is where we define those. This is the ligature. So we're going to define a ligature of irisCTF bracket RA. and we're going to give it a, I think this is horizontal advance, we're going to give it a width of 15,000, so absolutely huge. Then for every character, every single character, we're just going to give it a width of 0. And so every time I ask for a new font, so right now this is a font of known and guess, it's going to generate one. So like if I was going to continue, then I'm going to do re, and then I'm going to guess A, B, C, D. Eventually I'll get to D, and then I'll guess the A, B, C, D, and then A. And so we have, I think I save all the font files, yeah. So you can see this is me going through and guessing all the different fonts. And so there's a lot of different font files. Cool, let me change this back. So like I said, we generate this SVG, then we write it to disk. Then I use this tool called FontForge. There's some scripts you give it. The script doesn't actually do anything. I think it just says open and then generate a .wolf file. Not really sure what that's about, but it's necessary for the tool. It generates a bunch of text. We ignore it. And then we send that font back to the bot or the web page that's requesting it. And we make sure that there's caching on it. And there's also caching on this one too. Cool. Yeah, and that's pretty much everything. So we can try to run and see if it's going to work. Let me close this, reload. Let's make sure that the ngrok URL is correct. Goes an exploit. Is it 1A6? Cool. Let me check the flag. So we're only going to brute force the last two characters because it's really slow. And let's netcat. So we're going to go here. So this is the official challenge server. Make this a little bit larger. We're going to give it a URL, exploit.html, and hopefully this works. Cool. Are we getting callbacks? We are. Sweet. Okay. The first character already worked. So like I said, the first character was an A. All right, so we request the exploit file, we request what the current flag is, then we're going to load the CSS query. We're starting with a base flag of this. This is our guess. Then this is Chrome is doing a cross-origin request, so we need to make sure we have cores header on. I do the cores header. There's just a little tool called this for installing cores. So it responds to the cores call with an options, or the cores option call. Then it actually requests the font. And then from there, it goes on to the next one. We didn't get a callback here. There should normally be a callback, but because containerized queries are neat, A is the next character, we don't get a callback. So anyways, because of this, we already have the first letter brute forced. Actually, we go to B first, and then we know that we originally had the correct one because A is missing. So anyways, so we can see we were doing N3, and now we're doing N3A. And we got a callback here. So we know this is the callback script. So this is a leak. This is our known flag. And this was, sorry, let me make this bigger. This was the leak. This was our known flag. And this was our guess. Then we do the next character. This was our known flag. This was our guess B. And so we're doing that. And then C. And so it's going to go through all the letters, like I said, until it finds a gap. And eventually SOP to our S. We see it goes from S to U, and so then we know that we were missing T. And so just like that, we leak two characters, and like I said, you can do this through the whole thing. I don't think it can do, not easily, it can't do a closing bracket, so at this point, you would just check to see if underscore works or something, and if it doesn't work, you know you're done. So anyways, oh, we got a red. I don't know what that was about. Oh, I scrolled up too high. But yeah, that's the exploit. Super cool challenge. Super excited once I got it to work. And it's crazy that it works. Like, we're using CSS to steal tokens, going through Chrome's like XSS filter. Absolutely insane that this works. But anyways, thanks again to the challenge author. Very cool challenge. I'm glad to be done with the web section. There were a lot of great challenges in here, and yeah, thanks for watching. See ya.